Okay, how are you, everybody who is joining this workshop 2 of electronic schematic circuit diagram? I would like to take this opportunity to welcome every student into this fantastic class where we are learning the beauty of electronics in the special electronics drawing. So my name is Olenjolai, if it's the first time to meet me. And I want to tell you that we have covered about workshop 1, which actually we are learning about the electronic schematic symbols. So in case you have any questions, don't hesitate to ask me. I have some local students who are learning electronics drawing in one of the institutions in Tanzania. So I would like to respect their presence. Good evening, class.
Good evening, sir.
Good evening, class.
Good evening, sir.
I don't hear the voice of ladies. Good evening, class.
Good evening.
I didn't say ladies, all of you. Good evening, class.
Good evening, sir.
Oh, so ladies first always. Okay, so simply we've been learning about let us do the quick review. We've been learning schematic symbols of electrical and electronics components, because we say we need a schematic symbol in order to draw the schematic circuit diagram. So I have told you the schematic symbol of resistor. We have two symbols. We have international schematic symbol, and also we have USA schematic symbol. So we say that we can represent a resistor in this way, or we can represent a resistor as the boxing of this way. But also we have discussed it, or I have introduced you the schematic symbol of the capacitor. And it depends that which type of the capacitor we have. You can have either ceramic electrolytic capacitor, or you can have a ceramic capacitor. However, that sometimes we used to have variable capacitor. But I did not discuss, because I did not discuss in that terms, because in some cases where we just have few cases where you have to use the variable capacitor. But again, I've taught you the symbol of potentiometer or variable resistor. So you say that we use always to draw like this way. Then we discussed the schematic symbol 14 of inductor as another electrical components. We discussed the schematic symbol 40 class, DC or TDC power source or power sources. We discussed the schematic symbol 40 AC power sources. We discussed the schematic symbol 40 ground. We discussed the schematic symbol 40 switches, and I have just taught you some few switches, etc., etc., etc. So today we are going to learn about electronic schematic symbol of semiconductor electronics components. Are you ready for that? Yes. Okay. So the fundamental, this we call it R, A, O, or we call it the vowels of electronics or semiconductor. The fundamental device we have is called the diode. Say diode. Diode. Again. Diode. Again. Diode. Again. Diode. So what is a diode? What is diode? Can act as a switch. In one? In one way. So what is diode? Good try. So simply we say that a diode, however that the subject is symbol, a diode is a semiconductor, or we can call it in electronics component. Which allow the flow of electric current in only one direction. This is the simple definition of a diode. Only one direction. So in electronics we have different types of diodes, but we can have two categories of diodes. Categories of diodes. Remember that our interest or our point of focus is the schematic symbol. But before I teach you the schematic symbol of that semiconductor device, it's better to remind you what is it. Okay? So simply in electronics we have two categories of diodes. In electronics engineering, we have two categories of what? Of diode. The first one, we have a category called general purpose diode. And the second category we call it special purpose diode. So you have general purpose diode, get it? We have a general purpose diode and special purpose diode. Say general purpose diode.
General purpose diode.
Special purpose diode.
Special purpose diode.
So the schematic, because it's already electronics component, the schematic symbol of a general purpose diode is this one. So we have a triangle, and at the apex of that triangle we have a line. Oh no, how are you? How are you, Honorata? Good afternoon. Okay, so this is the symbol. So a diode, the general purpose diode, has only two terminals, anode and the cathode. Anode and what? So the anode is positive and the cathode is negative. Are we together? Sometimes this we call it ordinary diode. And it is the simplest diode. Okay? Are we together? In other words, if you want to go in detail, this anode representing P junction and this cathode representing N junction. Are we together? Are we together? So this is figure what? According to our configuration, figure what? Figure number 1. In connection to what we have learnt in previous number 9. And this is the component number what? Number 9, eh? Okay. So figure number 9. So you can write the schematic symbol of what? General purpose diode. Okay, class? Then for the special purpose, you say that in electronics, there are different types of special purpose diode. Examples, some few examples are: the first one, we have light emitting diode. Light emitting diode. In short, we call it LED. Light emitting diode. So when somebody asks you that, what the means of light emitting diode, how can you answer that question? So a light emitting diode is a semiconductor device or semiconductor electronics. It's a semiconductor component which produce or emit light when the direct current is allowed to flow through it. So I don't want to go in detail because I'm not teaching you with the semiconductor devices in your table, but I'm trying my level best to give you the overview because our focus is the schematic symbol. So we said the schematic symbol of light emitting diode. Let's stop writing. In case of the physical appearance of this general purpose diode, it is a cylinder shape. It has a cylinder shape. There's a cylinder shape. So in this cylinder shape, there is a part which is white in color. So with this one, we find that this is cathode, this is anode. For the light emitting diode, we draw first the symbol, the schematic symbol of the general purpose diode, and then we draw a small cycle surrounding it, and then we draw the beam, not the ray, because if you draw this one, we call it a ray of light. Okay, you remember? A ray of what? Light. But whenever we have more than one ray of light, we don't call them ray of light, or rays of light. We call them beam of light. That's what we taught you in the topic called the light, especially during your Form 1. The 9th topic in physics is Form 1. Do you remember? You were expert in physics those days. So that's why we have to draw this symbol. So this is the beam of what? Beam of light. So I just reminded you that this is the beam of what? Of light. So this one, this terminal is called the anode, and this one is called the cathode. So for the diode, this terminal we call it positive, and this one is called the negative. Listen, the physical appearance of the diode, of the light emitting diode, is cylinder in shape. The cylinder in shape. So this is figure 9A. This is figure 9, figure 9B. So this is physical appearance. Physical appearance of 40 of a general purpose diode. And here we have figure 10. Figure 10. So this is the schematic symbol of 40 of light emitting diode. And this is figure 10A. And here we have 40, figure 10B. So this is the physical appearance of 40 of light emitting diode. Why am I teaching you the physical appearance? Because you might think that physically a light emitting diode looks like this one. But another reason, I told you about offline electronic simulation software and online simulation. Good luck! And online electronic simulation software. Among the, I think that in offline electronic simulation software, I gave you one of example is called the free teasing. So free teasing, it does not use, whenever we choose a breadboard in free teasing, it will give you all the electronics components according to their physical appearance and not according to their schematic symbol. Proteus and some other offline electronic simulation software such as ThinkCAD, they used to represent or to represent the electronics components by using the schematic symbol. Okay? So this is the light emitting diode. Say light emitting diode. It can be either we have different colors with all different types of light emitting diode. We can have a blue light emitting diode. We can have a red light emitting diode. We can have a green light emitting diode. We can have a yellow light emitting diode. We can have white light emitting diode. We can have double color light emitting diode. We can have triple color light emitting diode. So we have different types of light emitting diode. In your mobile phone or in your mobile charge or in your computer adapter, you used to encounter these light emitting diodes in different electrical and electronics devices. For example, the red color in most cases usually to indicate the availability of power. So whenever you connect to some of the electrical and electronics devices, then you can find that either the light emitting diode or the green lights turn on. Right? So within that electronics or electrical device, there is a light emitting, but remember that the light emitting diode does not use alternating current. It uses direct or DC power. Are we together? So the long terminal is positive and the short terminal is negative. Class, are we together?
Yes.
Do you have a question? Why do you put that cycle? You don't see the answer of that question. This cycle represents the cylindrical structure of the physical light emitting diode. And we have different sizes of light emitting diode. We have small light emitting diode, we have medium light emitting diode, and also we have large light emitting diode. Okay? Oh, are we together? The second example of special purpose diode, the second example. So this is actual, don't write diode the second time. So I think that's, okay, 1.1, okay. The second example, we call it photo light. So why am I teaching you this concept? Whenever you see this symbol in any schematic circuit diagram, whether it is simple or complicated, you have to know that this symbol represents a physical light emitting diode. That's all. Okay? Whether in motherboards of the mobile phone or motherboards of the computer or motherboards of the television, we used to draw these symbols even on the PCB boards. You find that they've been drawn. Okay. So, now here, this is the point where we are. So, photodiode. So, actually, what is photodiode? So, the simple definition of photodiode say that this is the special purpose diode or semiconductor device which need the exposure of light in order for it to conduct electric current. So simply we say that the schematic symbol, I don't want to go too much details because we can deviate from the topic. Schematic symbol of photo light. So this is the schematic symbol of the photodiode. We have to draw the general or the symbol of the general purpose diode first. Then we have the cycle, like that one. And then we have beam of light. So this is the schematic symbol, figure 11A. So schematic symbol of what? Of photodiode. So a photodiode is a semiconductor device which needs what? Light, a particular amount of light in order for it to conduct electricity. Okay? So this one, actually this one converts light into electric signal, but it's not a transducer. And this one converts electric energy into light energy. Because it's electric current flowing and then it gives light. Okay? This one, it does not give light. Actually needs the what? The light in order for it to allow the flow of electric current in one direction. So also this is the anode and this is cathode. You should not claim about this beam of rays. Listen, this beam of rays can be here or can be located here, can be located here or located here. So you should not claim that always they should be at the top or whatever. No. Okay? The physical appearance of photodiode, the physical appearance of photodiode, it is cylindrical in structure. But in most cases, it's black. So it's what? It's black in what? Black in what? In color. So this is positive terminal, negative. So I'm trying to give you or to teach you the broad concept of the schematic symbol and the physical appearance. So physical appearance of what? Of photodiode. Okay? And when you talk about photodiode, you experience its functionality in your life. Where can you find it? Simply we used to find, stop writing and stop drawing. Usually we used to find the functionality of photodiode whenever we take something we call it lift. Have you ever taken a lift? Huh? Going where? Moving either from ground floor to what? Today? Floor number 5. So the entrance door of the lifting is rectangular in shape. So the sensors which are sensing that right now there's no any person that entering into the lifting are located here. So on this side there is, we call it infrared light emitting diode of this shape built within the door, the entrance door. And then on the other side there is photodiode. There is what? So this is infrared light emitting diode and this is infrared photodiode. So it means that the infrared light emitting diode produces the beam of light, right? If this beam of light will be detected by the photodiode, the door cannot close. The door has to close. When this one emits infrared radiation and this one detects it, so the door has to be closed. Okay? When, for instance, you want to enter, it means that you will not. It means that you will block the infrared light from the infrared light emitting diode towards the photodiode. So from there, the door will not close. Are we together? The good thing that we have those electronics components, I should not use a lot of energy to teach you why we have them. So I think that one day I can show you. Are you together? Yes. So remember that when we say photodiode, it does not detect any kinds of light. It detects light in particular frequency, wavelengths, and the energy. Are we together? Yes, so that is place where we used to find or we used to apply this photodiode. The third example of special purpose diode is called the Zener diode. Zener. Not Zener, but Zener. But you can discover that the name Zener is approaching to semiconductor device. So we call it Zener diode or Zener. Say Zener diode. So also it's a semiconductor device which has p-n junction and what? Or which has p-n junction, and it's a result of doping. But the only thing that this one conducts electricity from the n junction towards the p junction. So listen, when you say this is cathode, this is anode, this is cathode, right? So this is p junction, this is n junction. If, example, we wanted to supply electric current to flow through this diode, where are we going to connect the positive electricity? On the anode or on the cathode? If, example, we want to apply some amount of electric current, it was this photodiode, right? We have anode terminal and cathode terminal. Where are we going to connect the positive terminal of the battery? Anode, right? And where will be the flow of electric current? So current will be flowing from anode to what? Cathode. So for Zener diode, it works reversely. It conducts electricity because, for instance, if you supply the positive terminal, it means you supply the positive power at the cathode and negative power at the anode, there's no flow of current. So we say that the diode is in reverse bias. And according to what you have been learning that diode conducts electricity when it is in forward bias configuration. So today we'd like to update you. There are special diodes which conduct electricity when they are in reverse bias configuration. And a simple example is Zener diode. So Zener diode does not conduct electricity when it's connected in forward bias. Wonderful. That is good news for me. When I heard it for the first time, I said, hey, I want to learn more. Good luck, stand up. So the schematic is simple. So I don't want to tell you because the Zener diode itself, it's a lesson of 2 or 3 workshops. So that's why I don't want to go too much details about photodiode. So each of them, you can learn it for 2 or 3 workshops to understand at least the philosophy behind. Not to understand how it has been constructed, now, how does it work, and what are the components, what its internal architecture. Class, are we together? Yes. Are we together? Yes. So we go direct. The schematic is simple. So I will try my level best to explain to you verbally what does that electronics components do. Then we move to the target. The schematic is simple. Okay? Because I know some students, teacher, you are giving us a brief. Why don't you go to too much detail? I hate the photodiode. Maybe today I will learn what the photodiode, what is configuration, I will draw the potential barrier. That's another story. That's why learning does never end. Okay? But kibongo bongo learning ends, especially when you graduate a particular level. Kibongo bongo learning ends. But usual learning does not what? For instance, now if you say that we give you a certificate of ordinary diploma in electricity and telecommunication, do you think that the next semester will come here? Because you will ask yourself to do what? So the schematic symbol, sit down, good luck. The schematic symbol of a Zener diode is this one. So we draw, stop writing and stop drawing. Good luck, how do you see it? You can realize that most of these special purpose diodes, they have been designed from the concept of general purpose diode. Right? Right? So this is the symbol. This is the symbol of the general purpose diode. Right? But for the Zener diode, we are going to change this line a little bit and then draw something like this. So this is the schematic symbol. Figure what? Good luck, figure what? Good luck, this figure what? Good luck is not in the class. The schematic symbol of 40 of Zener diode. So this is still what? Anode. And this is still what? Acid. For this one, the conduction of electricity, this is the directions of electric current. Stop writing, stop drawing. But for this one, the conductions of electric current is from cathode to anode, or from N junction or N terminal to P terminal. So this is the conductions of electric current, and this is the conduction of electric current from anode to cathode. So this one conducting in reverse bias. So this one we call it reverse bias, and this one we call it forward bias. That's the principle. Are we together? Then, its physical appearance, don't worry. Its physical appearance is cylinder. So the physical appearance, this is figure 12A. So the physical appearance of Zener diode, it depends. If you open the motherboards of smart TV, it's a little bit bigger than this symbol, but its color is not like the color of 40 of the Zener of the general purpose diode. So this is the schematic symbol of 40 of Zener diode, and then here it has a particular color. So I don't know how we call that color, whether it's brown or whatever, but this is the schematic symbol. This is the physical appearance. So figure 12. So the physical appearance. Physical appearance of 40 of Zener diode. Are we together, class? Yes. I will show you because we have them. They are not in United States. The fourth example, it's the one that I'm not sure if we have. Ask your neighbor, do you like electronic drawing? Ask him or her loudly. When he or she says that, yes, I like, ask him or her, show me how do you like. And they ask your neighbor, the way you sit, does it indicate that you like the way you sit? The first example, we call it Schottky diode. Schottky. Say Schottky diode. Say Schottky diode. Possibly I've never heard them, but we are trying to open your mind. We are telling you, welcome to the world of semiconductor. You chose yourself, and there's no any way out. We have to take you through. Say Schottky diode. So this one also, it has its operation, principle of operation. It has its particular principle of operation, and it has its particular function in electronic circuit. And that particular function of Schottky diode cannot be done by either photodiode or Zener diode or light emitting diode or general purpose diode. So in particular cases, you need a Schottky diode. Hey! What are you watching there? Do you have a monogas? So the schematic. Smile before your neighbor. The schematic symbol of a Schottky diode is this one. So it looks like the symbol of. So look the way we draw. There's no need for you to create all of these symbols. You just have to understand the principle, and then you understand the appearance, then it's enough. Okay? Can you examine the drawings, the schematic symbols of your neighbor, left hand side and right hand side? Can you examine them if they look like mine, or he or she is drawing something else? I ask you to examine the drawings of your neighbor. Check the drawings of your neighbor, the schematic symbols of your neighbor. On right hand side and left hand side. Do that responsibility in order to correct him or her. Because I have noticed some students who are drawing something different. Nimesema angalia mchoro wa jirani yako kushoto na kulia. Inafanana ninachochora mimi au yeye anachora tu ili mradi achore. Sababu mwanzo alikwambia anapenda michoro ya electronics. Sasa kama anashinda tu kuchora schematic symbol, sasa atachora schematic circuit diagram. Have you examined it? How do they look like? Nice. Nice or interesting? Or worth? Kwanza anavochora, your neighbor does not have a ruler, neither a ruler nor a pencil, and possibly he or she does not have what? A rubber, or maybe your neighbor is drawing by using a pen. That's Bongoland business. So do you see how is your neighbor likes electronic drawing? So we draw the schematic symbol of Schottky diode from the general purpose diode. Look here on the blackboard, please. So then we draw this symbol. But the schematic symbol of 40. Heinrich is sick, according to what he told me yesterday. The schematic symbol of 40 of Schottky diode. So remember that there is no any small cycle. Okay? Are you together? These are the international schematic symbols. We also have some other, for example, we have tunnel diode. So the homework for this part, draw the schematic symbol of okay. Tunnel diagram. Tunnel diagram. Do you have a question? Ask it. Ezoti? Pardon? I did not explain the purpose. Yes, I said I'm trying to introduce to you. Every day of the day needs at least 3 to 4 workshops to discuss about it in detail and how does it work and what is configuration and how does it perform that task. For instance, the tunnel diode. This tunnel diode, it works just like a tunnel. The concept for the electronic scientist who innovated the tunnel diode is actually he took the concept of the tunnel. Do you know the tunnel? Eh? What the means of tunnel? Eh? We call them underway roads. You used to see them in the movie because in Bongole we don't have what? And we have them. Where? Kilosa. Kilosa what? Huh. Okay, possibly maybe it is. Okay, so simply the concept of the tunnel, the way it works is just like a tunnel. Do you know tunnel? Eh? Yani barabara za chini. Nadhani kwenye movie unaona. Si ndio? Kwa hiyo concept yani tunnel diode inavyofanya kazi na muundo wake ni sawa sawa na barabara ya chini inavyofanya ndio muundo wake. Sasa sitaki hapo kufunguka zaidi. And I don't want to go into too much detail because we'll deviate from the target and purpose of our today's concept. The only thing that which you have to thank God, today you had something which is called the Schottky diode. That is enough. So tomorrow you ask yourself a question. What is Schottky diode? Then the next day, what is internal configuration? Are we together? Yes. Okay. So you have brought the schematic symbol of 40. Eh? Tunnel diode. Then go and find another special purpose diode and another 7 special diode. Then once you find them, draw the schematic symbol. So I don't mention here the number 6 special purpose diode. You have to find yourself, but it should not be among the one that I've mentioned. And then find number 7 and then draw the schematic symbol. Is homework clear? Eh? Eh? So in total you have how many types of diode? 2? Eh? How many examples of diode will you have? Eh? Do you understand what are you saying? Okay, tell your neighbor if he or she can understand what you are saying. 5. I told you to go and find some other 2 types of special diode. So you have 7 plus general purpose diode, 8. Possibly you had only 1 general purpose diode, but at least today you have some more examples. It's a stage. Okay? Yes. Hey, so you have to go and make a follow-up. Is it clear the homework? Yes. Yeah? Okay, fine. Then that's all about diode or the schematic symbols of 40 of diode. We have some diodes which are crucial or actually that we are using in most of electronic circuit, and some of them we are using them in some special application. Are we together? Are we together? Yes. Okay. Faustina, did you understand? Or do you have a question about the homework? It's clear? Very good. If Faustina confirmed that the homework is clear, then I believe for all students it's clear. Why? Because Faustina always used to ask a question in homework, the clarification. And she's expert in that. So that's the expertise of 40, Faustina. How about you? Ask your neighbor. What's your class contribution? Do you used to ask questions? No. Do you used to answer questions? No. So what are you doing here? Wait! Stand up. Class A, transistor. Transistor. Ask your neighbor, what is transistor? Ask your neighbor and listen to the answer. So what is what? That is homework. Yes. Go and find the definitions of the word transistor. So you say that in electronics, types of 40 of transistors. Remember that my responsibility in this workshop is not to teach you about transistor, it's not to teach you about diode, it's just to teach you about schematic symbols. Schematic diode. In electronics, there are, what are you discussing with your neighbor? Two types of 40. Transistor. Ask your neighbor, will you call your firstborn transistor? Ask your neighbor, will you call your firstborn transistor, your firstborn child transistor? He said yes. Okay. So we have so in electronics, we have how many types of transistor? Two types. The first one is common. We taught you in ordinary level education. We call it bipolar junction transistor. Have your seat. Bipolar junction transistor, in short we call it BJT. Zener diode is talking. Zener diode of your class is talking. That's the first type of 40? Transistor. Yesterday you have been learning about parts of computer. What the main part of the computer? The main part of computer. CPU. Okay. The second one, the second type of transistor is unipolar. Unipolar junction transistor. So this one, in other ways, we call it a field effect. Field effect transistor. So its abbreviation is FET. So in electronics you have what? Bipolar. Say bipolar. Say bipolar junction transistor. In short, we call it what? BJT. So you have to call your second born BJ. Your third born, there's no need for you to look for the names. Because you know, when you have a first child, you'll ask your friends, I have a baby boy or a baby girl. What name should I call him or her? Darlington. Darlington what? Try your level best to call your children the names that you can give descriptions. What do they mean? Because you might call him or her Darlington, but yourself as the father or the mother, you don't know what Darlingtons mean. Say unipolar junction transistor. Or say field defect transistor. AKA is FET. Eh? Ah. So this is because it's a heart of electronics. The world, it has been changed by the after innovation or the world it means something. The technology and the electronics engineering has been changing gradual or has been changing exponentially since the innovations of the transistor. So the transistor still have a great contribution in the world of yesterday, the world of today, and the world of tomorrow. Okay? Okay? So the first type is what? It's called what? Bipolar what? Junction what? Transistor. So this is the name of what? Your second or third or fourth one. Ask your neighbor, how many children do you expect it to have? Until then. Filippo? As well as you can. As well as you can. Ask your neighbor that question. Very important question. And because you've been living together with your neighbor for a long time, you will prove his or her answer. So ask him or her, because he or she might answer it carelessly. So later on you'll come and say, do you remember one day you told me that you want to bear 10 kids? So now, why are you saying 2 are enough? This is question what? Zina Dade? Question 4. So if you want to call your second one bipolar junction transistor, so ask your neighbor, what is bipolar junction transistor? Eh? Question 3. What is this? Question 2, eh? Okay, you are very good in numbering. A bipolar, Zina diode now is what? Communicating. A bipolar junction transistor. Bipolar junction transistor. The type of transistor. This is one of the definitions, the type of transistor that conducting electricity by using electrons and the holes as current carriers. This is the simple definitions of bipolar junction transistor. What is bipolar junction transistor? So if you call your second born bipolar junction transistor, so you expect him or her to conduct electricity by using what? Electrons and the holes. Is it interesting? Huh? No. Why? It's not interesting. Types of bipolar junction transistor. We are heading to the schematic symbol. But I have to start I have to teach you any concept in the big picture. So we are going. Types of bipolar junction transistor. In electronics, engineering, and science, there are two types of bipolar junction transistor. Namely, the first one is called the NPN bipolar junction transistor. Filippo, today you are not writing. I don't know why. I don't know your plan. I don't know. We don't know the plan of Filippo today. Why he's not writing? Maybe he wants to accomplish what we said in advance. You are writing, but you start like you are in the office waiting to sign some document. Say NPN bipolar junction transistor. Say NPN bipolar junction transistor. PNP bipolar junction transistor. Nyamegi. Nyamegi oye. Nyamegi oye. Nyamegi, are you in the class? No. Nyamegi is not what? In the class. How are you, Nyamegi? You are not okay. You are fine. But you decided to be serious. Okay. So what the meanings of all electrons, you know them, right? What the meaning of electron? When somebody asks you what is electron? Huh? Class, can't you define electron? We taught you the concept of electron since primary school. But also introduced you in physics form 2, static electricity. We introduced you the positive charge and the negative charge, which we call the electrons. So when somebody asks you define electron, how can you define? Is there? Is the negative charge of who? Particles. Is the negative charge atom? Huh? I don't know how you learn electrical concepts and electronics, but electrons, it's a negatively charged subatomic particle which has a quantity of charge of 1.9 exponent negative 19 coulomb. So ask your neighbor, where are you expert? Semiconductor, you are not there. Resistor inductor is another story. Diode, again. Okay, but tell your neighbor, don't worry. That's why you came for learning. So, what is the meaning of holes? Holes are the positive charged particles. Another idea? Pardon? Is formed when electrons leave the shell. Another response. What is the meaning of holes? They are positive charge carriers. Another concept. Can we find holes in any material? Okay. Some of you have said the only thing that you're missing in your definition for all the 3 students. Okay, it is true. Holes are the positive charge. It's true also holes are positive current carriers. And it's true that holes are the empty or vacuums which have been left when electrons has been what? Excited. From where? Valence band to what? Conduction band. You forgot. But simply say that all of those 3 ideas are correct. But the one that the keyword that you have been missing. Holes are always found in semiconductor devices. Holes are only found in what? Doped semiconductor devices. Because we have intrinsic semiconductor and extrinsic semi, right? So holes are always found in what? So holes are the positive charge current what? Carriers. Okay? That's the means of what? Of holes. So the NPN junction, for the NPN junction, here we have how many junctions or how many terminals? 3 terminals. N terminal, guard me. Concentrate please. N terminal, P terminal, N terminal. So in this one we say that because we have 2 types of current carriers, the amounts of these current carriers vary according to the type of the transistor. For the, this is 2.21.1. So 2.11 NPN bipolar junction transistor. Say NPN bipolar junction transistor.
NPN bipolar.
So for the NPN bipolar junction transistor, we say that the electrons are the majority current carriers. The word bi in science and mathematics means 2. That means of the word bi. Bi and die in science and mathematics means what? Bi and die means what in mathematics and science and engineering? 2. Bipolar, it means that we have 2 polarities, negative and the positive. That positive we call it what? Holes. Okay? Di, for example, we say that carbon monoxide and carbon dioxide. Right? So dioxide, di means 2. Di means 2. Right? Right? For example, we have monocotyledon and what? Dicotyledon. Those are the terminologies we have been teaching you to build the concept. So whenever you hear the word di, especially that if it is a Greek word, then you have to expect that means 2. The word bi, I have another example of bi. Another example, according to the science. By what? Huh? By biology. Biology. So biology is a combination of what? Zoology and the botany. That's why it was bi. People think from the beginnings of this subject, I've been trying to teach you to use your mind to think, but you used to reject it because you are expert in cramming and thinking about looking for the marks. That's all. Okay? So biology means see? Eh? So we say that in NPN bipolar junction transistor, the electrons are the majority, say majority. Say majority current carriers. And for this case, the holes are the what? Are the minority current what? Current carriers. When we talk about electrons, we are talking electrons within the semiconductor. When you talk about holes, we are not talking the holes within the conductor. We are talking the holes within the semiconductor. For example, the wire, it's a conductor. Copper wire, it's a conductor. Aluminum wire, it's a conductor. Right? Constantan wire, it's a conductor. Right? Iron, it's a conductor. We are not talking about electrons and holes within the metal. We are talking electrons and holes within semiconductor. Okay? So when you talk about electrons are the majority carriers and the holes are the minority carriers, we are discussing about the current carriers within the transistor. And why electrons are majority carriers and holes are minority carriers is very simple. Because in this transistor, we have high concentrations of electrons more than holes. Okay? So this one will have a number of electrons. And these junctions, or this terminal, will have a number of electrons. While we have only holes in this terminal. Are we together? Remember that the electrons are always contributed by what? N dot dot semiconductor. And holes are contributed by what? P type dot dot semiconductor. That's why we taught you all of those concepts. Is it clear, class? Okay. The schematic symbol of NPN bipolar junction transistor is this one. You can draw this schematic symbol in different ways. Stop drawing, look on the blackboard. This terminal is what we call TP. And this is what we call TN. And this is what we call TN. So NPN transistor. Okay? Then this P terminal is the one that we call the base. And this one is the one that we call the collector. And this one is the one we call the emitter. Are we together? Are we together? So in order to distinguish NPN bipolar junction, the schematic symbol of NPN bipolar junction transistor and PNP, we just indicate whether the current flowing outside of the transistor or inside the transistor. So the arrow is always located in emitter terminal or in N terminal in case of NPN bipolar junction transistor. This arrow indicates the directions of flow of current. Do you know why? Can you ask your neighbor why that arrow is there? We taught you the C biasing of 40 of the transistor. And as we taught you one of the mathematical formula, we say that the emitter current is equal to base current plus collector current. Okay? Okay? Stop writing, look, and listen. So for this case, in case of the base, so the base will always supply current to the, I said class, stop drawing, stop writing, listen and look on the blackboard. We said that the base is always supplying the current to the transistor, right? And also the collector is supplying the C current to the transistor. So simply this is what we used to call the base current, and this is what we call the collector current. So base current and collector currents are summed together and leave the transistor through the emitter terminal. And here, this is the point we used to have emitter current. That's why we say that emitter current is equal to base current plus collector current. Simple like that. But in case, for the purpose of just schematic, this is the schematic symbol of 40 NPN transistor. So this is figure 40. Figure 40. Helena. Figure 40. Helena, figure 40. 14. 15. So schematic symbol 40 of NPN transistor. Okay, so then we have 2.1.2 is called the PNP bipolar junction transistor. In most cases of electronics, we use NPN bipolar junction transistor rather than PNP bipolar junction transistor. Okay? So the question, you don't know meaning of electrons and meanings of holes. So that's why you cannot answer the questions why NPN is most useful rather than PNP. The reasons is according to what? To the science of holes and electrons, which you have never bothered you about it. So in the PNP transistor, we say that the majority, we say that the holes are the majority. The holes are the majority current carriers. The holes are the majority current carriers. The holes are the majority current what? Okay? Huh? The electrons are what?